Hi, and welcome to yet another episode of the FRG-7700. Certainly seeing our way around this one. I've got a few things I'm going to do, well, a couple of things I'm going to do now. Firstly, at the top of these diodes that feed in, that come from the band switch, feed into the circuit. They are measuring okay in circuit, but that's not to say that they're still not dodgy. As I say, it's thought that they could be weak. I've got a load of these diodes, so I'm just going to go in and replace them. There's what, 1, 2, 3, 9, 10, 11, 12, 16 diodes there left to change. So I'm going to swap 16 diodes out. The other area on the circuit I want to have a look at is down here. Now, this is, as far as I can see, this little circuit in this area is the loop filter for the PLL circuit. Basically, this stabilizes the circuit. And there is another VFO in here, which I didn't realize until I sort of did a bit more reading up. You can see the varactor diodes in here. So we have got another VFO here, which feeds a signal back in and up into our main chip there, Q42. So if there's anything wrong in this area, it certainly is going to fetch the frequency. Let's say we've got our main 4 VFOs up through here. If you can see that, where am I? Yeah, so this is our main 4 VFOs that I've been concentrating on, with VFO 3 being the likely candidate, because that was the VFO that contained the frequencies that were playing up. But as I say, we have got this circuit down the bottom feeding back into that main PLO chip. So I'm going to find this. I can't find this at the moment on the circuit, so I'm assuming that it's in underneath this little devil at the back here. This is it's possible it's all enclosed within there, and that's where we're losing the stability. So that's quite a fine adjustment. So, as I say, it's diodes which are down in here. Let's see if I can get you in there. It's a bit dark. I need to get the light back over this way a bit more. There we go. So yeah, the diodes I'm going to be changing are, this over a bit. Can you see that? I'm not sure. Probably not. Let's just pop you down a little bit closer. There we go. So you can see this row of diodes down through here. All of these are going to come out, and these up through here. You can really see, yeah, so all of those up through there, and this row coming off the band switch along here. I have messed with these, and as you sort of touch them, and it does scramble the frequency a little bit, so it could well be something to do with that. So this board, once again, we're getting an expert at taking this board in and out. Now if anyone wants any advice on getting a board out of these, I'm the man. So this board, the PLO board, is coming back out again, and hopefully we're getting closer. We are getting closer. Can't be much more. So bear with me, I'm going to get that board back out. Okay, I have the board out once again. Okay, so you can certainly see all the diodes there now. So you've got these that are laid side on here. These are all stood upright. There's one that's a bit bent there, and I think it's going to be good to get rid of those. I know, speaking to Greg, he had this is the issue he had with his, was these diodes on the switch side here. So I've got a load of those. I've got some, I must have picked them up at Radio Rally or something. I've got quite a few. I've also found the what I think is the loop filter circuit. It's quite dark there, isn't it, for some reason? I don't know why. Perhaps my light's playing up a little bit. Let's get down a little bit closer. So It's here is the chip I was looking for, and the reason I couldn't find it is because it's actually a different chip than is listed on the schematic. It's Q25, and on the schematic it should be MC4044P, but I appear to have an NEC. It looks like, let's go this IIPC10080. So whether that's an equivalent, I don't know. Looking at the back of the board, it's this chip in here. You can see that. Where am I? Here we go. Yes, this chip in here. It doesn't really look like it's been swapped out, so it looks like it's factory. So it doesn't look like it's been soldered. So yeah, not sure what's going on there. Maybe this is a later one that's been modified in some way. Yeah, unusual. Also appears, I don't know if that's me. Yeah, that's me taking stuff out and checking there. But yeah. So this is the area I want to look at next. And I'm not sure where the varactor is. So we've got these two transistors here that are in the loop circuit. That's normally formed with capacitors and resistors, so certainly these three caps are going. Let me get a shot of those and put my niche cons in. Just trying to find where the varactor is. I reckon that's in here. I reckon that's inside there. Just trying to look on the circuit diagram now. Strange, it shows the TOs in here, but it doesn't actually show the slug in them, which is unusual. Look there, so TO7. TO7, well that has got to be TO6. TO5, yeah, it's got to be that one in there, I'm sure it is. So the varactor is going to be inside this metal can, which is actually, for some reason, they've waxed that as well. Anyway, we're going to get in there as well and have a look at that, so bear with me. I'm going to do a bit of desoldering now. Okay, so pulled out these diodes. I will stick them on the tester. Desoldered them at the moment. Only takes one to be slightly dodgy, I suppose, doesn't it? Seem to have magnetised my forceps for some reason. So that's the first few out. In fact, that's 1, 2, 3, 4, 5, that's 8. So I'm going to do those first. Let's find some diodes. And we'll straighten these up and make them look nice and neat. Because I'm fussy. So it's not a difficult job really, just need a bit of patience. And apologies to Clint for hanging on to his radio for so long as well, but I've been sort of trying to do it in between work, etc. You know what it's like. Weekends never seem long enough. and all of that. I must get me a fume extractor. No, if I get there, you're not going to see, are you? No. Do a couple of these by eye, and then I'm going to go off camera and do the rest. So that's the first one in. You get the gist. So I'm going to go along now, solder them all. I'm just going to use the magnifier just to make my life a bit easier. Okay, there we are. That didn't take, what, probably took me 15-20 minutes. That does help so much with that desoldering tool. So all these all changed, these changed, and all these have changed. I did notice, strange enough, that these have been bent in a specific way. Strange, isn't it? Obviously the engineer or whoever, I don't know whether these boards were put together by hand or whether they were put together by a machine, but these diodes are all bent in different directions to try and keep the body of the diode near the symbol on the boards. I don't know whether that's for any reason, but you know, I thought I'd stick with it because that's how it was. So yeah, as I say, that's all done, looking nice and neat, so I'm pleased with that. So now on to my next job, which is, if I can find the camera, these 3 capacitors are coming out next. Okay, right, I've been busy. It's not taken an awful lot of time, to be honest, but I've made sure I've done it properly. So what have I done? I've replaced the diodes all down through there, all of these. I've had a look at this circuit, replaced the capacitors. I've replaced these capacitors, and I've replaced the capacitors down through here. I've replaced the capacitor in this VCO. What else have I done? So, but yeah, basically now this whole board has been recapped. All new diodes in the switch area. It's had a new chip here. What else have I done? All of the VCO has been out in this area. I've checked all the transistors in that circuit to make sure they're all okay. So really, I'm starting to run out of things to do now. So what I've got to do next, I've got to clean the board up with my lovely soldering. Give that a good clean off. I'm just going to check over all the base of this once more with the magnifier just to make sure there's no suspect looking joints. If there is, I'll reflow them, but I've already done that once, so should be okay. But, yeah, there we are. So I'm just going to get my flux cleaner out, clean all this off, then rinse it through with some isopropyl. Okay, welcome back once again. So I've done some work on this one. My next plan to do, it's still not performing properly, so I want to go back through and do another alignment, because it seems that every time I do an alignment it seems to change. So I'm just going to try a couple different things. So first of all, I'm going to do the counterclock frequency adjustment, and that is connecting the frequency counter to test point 7. It's getting underneath there, which is down here near the centre of the board at the front. If you can see that, say I'll get a little bit closer. There we are. And I'm looking for a frequency reading of 3.2768 megahertz on counter, and if that's not quite right, I've got to adjust TC1003. Okay, so the trimmer I'm going to be adjusting is this one down here, if it needs adjusting. There's that one in there, look. So hopefully you can see that. I'm not sure if it's focusing or not, but that's the one I'm going to be adjusting. So I'm going to zoom back out and let you see the actual frequency counter as well at the same time, just to see what we've got. Facing that capacitor there. Okay. So I need to come clockwise a fraction. Just let that stabilise. No, still nothing. Let's go a little bit further. There we are, 2768. There we go, that's very stable, so I'm happy with that. Okay, I'm just setting up now for the SSB carrier frequency adjustment. So frequency counter is connected to test point 1005, which is this one. And I'm looking for 456.5 kilohertz on the frequency counter, and the adjustment is a little capacitor trimmer TC02, which is this one here. So the capacitor trimmer that I'm going to be adjusting is, can't quite see it, can you? No, just in behind this bundle of wire in here. But so let's get the frequency counter in shot again and show you what I'm up to. Okay, so I'm going to connect it up to the test point, and I should have a reading on there of 456.5. So I got, it's a bit random, it's 4, yeah, it seems to be scrambled for some reason. Let's give the trimmer a turn and see where we are, if I can find the adjustment screwdriver. So it's capacitor, trimmer capacitor TC2, which is that one. So I'm looking for 4565. Okay, back to where we were. Just going to put a little dot on there where it is at the moment. So that frequency certainly is not stable in any way. So it should be 4565. So let's go this way. Throw the other way. Doesn't seem to be making any difference at all, that, for some reason. Let's try a different gate times. 4, 6, 7. That's just not right, that. I don't know whether it's my counter, but they seem to be measuring the other frequencies as they should be. 4, 5, 6, 5. Let's see what it's reading on lower sideband. That should be 453.5. It's bizarre, those trimmers are absolutely making it no difference whatsoever, which I find a bit strange. So definitely we should have a difference in frequency here, so 4737 on upper. Full 660 on lower. No, something's not right there. So be sure I've not got anything wrong on the front here. EGC, no, that's fine. Doesn't really matter what band I'm in. The memory's not switched on. No, really unsure why that's making no difference whatsoever. Yeah, can't make that one out. So I'm going to leave it as it was. But yet another mystery. Okay, I'm back on this one. Carrying on with the alignment, I'm just aligning the PLL here. As you can see, I brought my trusty Avometer 8 Mark 6 out to help me with this one. So I need something to help me. I've lost my screwdriver now. There we are. So this is a fairly critical measurement. This is doing the VCV line adjustment. So I've got the dial set to the 1000 mark. And I should be seeing 7 volts. I'm a fraction under. It says get it as near as possible. So it's very touchy, this one. It's a fraction and I'm under. Yes. There, well, that's pretty bang on. I don't know if you can see the meter. Hopefully you can. It's bang on 7. I've already done the PLL local alignment using my scope. Let's just do that again for the camera. So see, I've got the service menu up on my iPad at the moment. Let's get that one out of the way. So for this one, PLL local alignment, I've got to, it says RF probe for your vacuum tube voltmeter. Well, I haven't got that, so I'm going with the scope. That is to test point number P1 of J2005. Oh right, okay, J2005 is actually this jumper down here. Pin 1 is that one. So I've got the scope probe in pin 1, crock lead to ground. And it's looking for maximum reading on the VTVM, adjusting, there's two little transformers down here, two little coils down in here, so if you look up at the scope, I'll get you in on that. It's a bit brighter than the other scope, this one as well. Let's get you right in on the scale. Okay, just pop the volts per division up a little bit and stick it roughly in the centre. So just check there's nothing else I've got to do. Yeah, maximum reading. So what I'm doing is turning these two small coils. So just triggering a little bit. So you can see it's certainly having an effect there. Let's try the other one. Hopefully not watching the top of my head. As you can see, that is peaked. Let's just pop it up a little bit bigger on the screen. Show the waveform there. Okay, sorry about that. Phone always rings when you don't want it to, doesn't it? Right, so let's look at this trace again. So let's have a look at the, as you can see, as I'm turning it, it's going down up to the peak and then it's backing off. So peak is there, and the second one that's it, peaked it there. So that's as good as I'm going to get that. So that's that adjustment done. And as I say, that is done in the J05 jumper and the two transformers. So what's next? Okay, so you should be able to see my MFJ. It's an antenna analyzer really, but it has got a frequency mode, so let's just pop it on. Hopefully you can see the display there. Yeah, you can. Let's go into frequency counter mode. So now I'm connecting back with the frequency counter now to the same terminal. Let's earth that out. And I'm looking for a frequency of exactly 47.6. It's jumping around a little bit. Let's see if I can get it in a little bit tighter. Let's try a different gate. So I've got to adjust TC2001, which is a little trimmer capacitor down there. Let's get my bigger ceramic screwdriver out. So I'm looking for, as I say, 47.6 megahertz exactly. Takes a little while to change. Doesn't seem to do a lot, this one, to be fair. Let's go all the way around. Strange, that trimmer seems to be having a very little effect on it. That is definitely the right one though. There is no other trimmer. As I say, this is not the most accurate frequency counter, and I've got another one on the way, but yeah, I should be able to achieve that on this one, but just not going all the way. 47.6. Let's put my iPad down, I can get in there a little bit better. So it could be that that crystal's a little bit lazy. Try a different gate. Come on, 0.1 of a second. It's very close, mind you, but not quite there. This capacitor should trim it back. Seems to be having no effect whatsoever. Okay. So I've got a couple other little capacitors in that circuit that could that alters as it heats up. Let's just put my finger on it just to warm it up a bit. That's about as good as I can get it. 596 without messing with it. I don't want to mess with it, to be fair. In the right one, aren't I? Yeah, the other one's a shield. That's definitely the right pin. Let's try with it disconnected. No, absolutely no difference. Let's try the other pin, make sure we've got the right one. Strange, I can't trim that one in really. Mystery. And say, I suppose a small little thing like that could throw the frequency out, so maybe I need to investigate that. So it's saying now to return the dial to the 0 position, which is this way. Get that zeroed on the analog scale. Doesn't matter what frequency you're on at this stage. We'll test that test point again. So go back in where I did the 7-volt test just now. And on the 3-volt scale, let's just see what it zeroes out like on the 3-volt scale. Yeah, pretty good. So basically, it needs to be within 1.5 to 2 volts. Well, it's 2.5, just over 2.5 volts here, but to be honest, everybody's, well, certainly on the forums, they're saying that these readings are only approximate, and there they differ really on all sets. Well, that's reading, it's not changing at all. So it's 1.5 to 2 volts, some 2.5 volts. Not a lot you can do about that. Now we need to change it to test point 3, which is over here. Let's get the scale right on the multimeter. Let's get you in on the scale of the meter so you can see a bit better. So I'm on a 10-volt scale at the moment, DC. I've got to now put it up to the 1000 position again. Spin that round. There we are. So band switch to the 5 megahertz range there. Just T2004 now, I believe. Yeah, this is the VCOs now. So, I just knocked it off there. We should be 7.4, while I'm a smidgen under. So I get into the VCO. .4. Then the 12 mic band. That's there. Should also be reading .4 while I'm 7.3, just under 7.4, so that's be difficult to move. There's a lot of muck in there. There we go, 7.4, fraction more. Very, very touchy, these. Especially this one by the feel of it. There we go, 7.4. Then on to the 20 megahertz range. That, at the moment, for some reason, it's only showing. Let's just give it a little tweak, see if it does anything. No. Strange. So 29, slightly out. Let's go back to 20 again. For some reason we've lost voltage on there. No voltage going to my problem at VCO as well. Oh, there he is. Bizarre. Obviously that had locked up then. So now set the band switch to 21, and it should be between 1.5 and 2 volts. Well, that's fine there. Let's put that on the 3 volt scale. So it's under 2 there. So what have we got? 13 and 0. 13. Under 2. Oh. So a needle hammering across the end. And 0. Slightly high.